right, so here's our graph for the first one. We went left 6, and its absolute value, it's upside down because of the negative. I usually just use the negative 1/3 as the slope, like we went down 1/3. Walking around though, graphing that looked like it went really well. So again, I'll fill all this in and you can check these answers. Like I want you to check these answers before the test, but let's just look at the end behavior. So it would be limit, just LIM, x arrow negative infinity. It's limit as x goes to negative infinity. That's just the way of saying look to the left side. Where does the function go? So where is the, well, where are both of these arrows pointing actually? Yeah, they're both going down, so they're both negative infinity. So the other one's going to be the exact same thing, except we're going to look to the right. It'll be limit as x goes to positive infinity. The function also goes to negative infinity. Usually I'll see like an equal sign there. If you want to put an equals arrow, I don't care, but like that's how that notation works. If you write it the way you did last year with the as, I'll take that as well for right now. Like I eventually want you to kind of get on board with this. But that's how that would get written. They're both going down. Really fancy way of saying both the sides go down. I want to do a good bit of this one together. Now the graph's probably the easiest part because I'm not picky about the points. Just like the asymptotes in there. So what directions did this shift? Left 2, good. Down 3. Okay, watch, guys. Here, I'll use a different color. We're going to go left 2, down 3, and then just draw in the graph. As long as you have the asymptotes dotted in, I don't really care that much about the rest of this. Like, I'm not super picky about that. Just dot in the asymptotes and then draw the graph. Let's do this whole problem, okay? Because fractions can be hard. Domain, scanning left to right. Who is not invited to the domain party? Leave. -2 is a troublemaker. Kick him out. So we want everything to the left of -2, everything to the right of -2, but not -2. That has to be parentheses, because if you put a bracket, you're including -2, and we want to kick him out. Range is the same thing, except you're doing y values. So who is not invited to the range party? Literally, it is that, except just put -3 instead. I'm going to come back to the intercepts. They're a little tough. Do you remember when we did the notes on this and I was like, here, you're going to have to work out a problem off to the side? Like it's going to involve steps and stuff, like algebra. Okay, we'll come back to this. Increasing and decreasing. We're going to read left to right. Watch me point to this. I'm not teaching you what increasing and decreasing means. You walked in the door knowing that. What I'm teaching you is the notation of how to write it, like the annoying part, okay? As we read left to right, what is this graph doing? Going down. How about over here? What's it doing? Going, yeah, good. You got it. Going down. It is never increasing. So that is none. Or you can put NA, or you can put nope, or you can put a frowny face. You can be creative, but you have to put something on that line, because if you leave it blank, then I don't know if you forgot to answer it or what. Now it decreases all the time. That means for the entire domain. Just copy the domain answer over again. And the reason for that is because we read left to right. I usually get asked, hey, Ms. Cole, will we ever copy the range? No, you will never copy the range. It's always left to right. It's always the domain. Here's another question. Ms. Cole, what if my domain's wrong, but I copy that answer over here? I will mark it off for the domain and give you complete full credit here. Does that make sense? I'm not going to take off twice for one mistake. All right, vertical asymptote, x equals or y equals? Good, point vux, x equals -2, good. And then the horizontal would be y equals -3. That is a thing that is very easy and also very easy to get backwards. So just be careful. All right, end behavior, limit x goes to -infinity. Where does the function go? -3. Good. Do you see how it's leveling off at -3? The other thing I'll tell people to do, because they're like, Miss Cole, I had somebody say one year, she was very upset. Miss Cole, there are arrows everywhere. Which ones do I look at? And I was like, valid. Like, that's valid. So I said, take your hand and cover up the middle of the graph. It's not middle behavior, it's end behavior. Cover up the middle of the graph. Do you see these two ends? Those are the arrows you want to look at. Do you see how they both level off at -3? I don't know, for whatever it's worth, if that helps. So the right end also goes to -3. All right, you're gonna have to work for these two. An X-intercept, which there is one, it's like there-ish, I just don't know exactly what it is. It's gonna be something, 0. You have to take this entire equation and set it equal to 0 and work it out. That involves some work. You just can't be afraid of doing work, okay? But I believe in you, and it's just algebra. Make your Algebra 2 teacher proud. Whoever was your teacher last year, make them proud. +3, whoever said +3, thank you. +3. All right, then what? Good, and you need to give it a hug, all right? So you're gonna multiply that x plus 2 to the other side. You would have 1 equals 3 times x plus 2. Now we have it down to more of an algebra 1 kind of problem. What did you say? Oh, okay. Whoever said distribute the 3, thank you. If you distribute the 3, that'll give you 3x plus 6. And then, see, do you feel like you're almost home at this point? You're like, oh, I can get it. -5 equals 3x. -5/3. Y-intercept is going to be 0, comma something. For that one, you just plug in 0. So if we plug in 0 for x, 0 plus 2, 2. So it's 1/2 minus 3. Now, yeah, see, okay, you guys are able, that's so awesome, because you guys are brilliant. You're able to do that one in your head because it's halves, and we can just manage halves in our heads. Pretend it was sevenths. Do you know what I'm saying? Or something really weird. Let me show you how to work through it. You're able to just do it in your brain because it was a nice fraction. What you would need to do is rewrite the 3 as halves. $1,000,000 question. How many halves is a whole 3? You guys have got that. Nice. 1/2 minus 6 halves. 1 minus 6 is -5. Good, okay. Cool. All right. Again, I won't have time to do every single one, but I'm going to do as many as I can for you. On this side, can you look through and see if there's anything particularly scary? Like maybe do you want to graph this together? Like, do you feel like if you got the graph, you might be able to answer most of the, okay, let's do the graph together then. It shifted what direction? Right 1, I know it's backwards, and then down 5. So go right 1, down 5. If you're like, hey, but what about that negative? What did that negative do? It flipped it. So instead of, here, just watch me point to it. Instead of going this way, it's gonna go that way, okay? So let's try and plug in some numbers. If we plug in something that doesn't work, we will do try again. But you wanna plug in numbers going this way. So if we're at 1 here, maybe let's try 0. I actually didn't work that out in my head ahead of time. We'll see if that works out. 0 minus 1. -1, but we're gonna negative it, so it's a, oh, good. Square root of 1, 1, -5, -4. 0, -4. Oh, I love that that's 0, comma, -4, because that's also this answer. Let's try and get one more. I need to plug in negative something. -3. Let's see if that works. -3 minus 1 would be -4. This makes it 4. Good. Square root of 4. 2 minus 5 is -3. I love teaching pre-calc for like that exact reason. Like, did you guys hear what happened? Like, you guys don't even need a calculator anymore. And it's like, we're only 1 month into the school year. It's awesome. Everybody like learns so much in this class. It's so good.
Yeah, you did negative. You did the wrong one.
Oh, did I put it at -2? I'm sorry. I'm sorry. I was just so proud of you guys. I like messed it up. Now, the only one out of the rest of these, because I think you would be able to do the rest of that probably just fine, or at least if you like checked your answers, you would be like, oh, I get it. But let's do the X-intercept, because the most common mistake I get there is people put none, and I totally get why that happens. But do you get that this is going to keep on going? Like, it'll eventually hit over here. So we're going to have an X-intercept. We just need to work it out by hand. All right. So we're going to take this entire thing, set it equal to 0. I'm just going to use some of the space that I have over here. Just kind of write little. You'll be okay. So what would you do to both sides? Add 5. Good. Why do we square? Good. So 5 squared, 25. Now you could go one of two ways here. you could distribute that negative, or you could just divide the negative to the other side. Here's what I would do. Watch. I feel like this is the least amount of work, but if you look away, you're going to miss it. Watch this. Are you ready? Are you ready? Like a magic trick. And then your last step would be add 1. So you would get negative 24. And then you would go, hey, does that make sense that it would be all the way out here at negative 24? Do you feel like these ones would go okay? I feel like 4, 5, and 6 would maybe be all right. Just make sure you write these maximums and minimums backwards. Like whatever the point is, write it the other way around. Okay, let's do number 5. Or well, 5 doesn't have a constant part in it. Let's do 6. What is this graph doing first? So we decrease from negative infinity until 1. Beautiful. We're constant from 1 to 5. And then we increase 5 to infinity. Just read it left to right. I feel like that one is what you guys call slight, right? Like, what? All right, let's do number 7. Oh, sorry.
I don't go outside. I don't know what you're saying.
For these ones, I don't care if you put bracket or parentheses, except for on infinity. Hey guys, I'm trying to answer a question back here. Grace, I've got it right here. For these ones, you can put brackets or parentheses. I don't care. Doesn't matter, except on infinity and negative infinity. What do you have to put on infinity or negative infinity? Parentheses, because they aren't like a value. It's not like a number of something, so you can't bracket those. All right, find the value of a that makes the function continuous. Continuous means the two pieces need to connect. So by instinct, what do you want to do with these? If you need them to connect, what are you going to do with them? Equal them. X plus 5 equals ax squared minus 1. Set them equal. You get a point for doing that. It's like a point for each step. Set them equal. If you realize you're supposed to set them equal, you get a point. Now, where is the cut point? Like if you actually cut this apart. Good. Plug in -2 for x. Everywhere there's an x, put in -2. This one needs a hug. And then we're going to solve it. It is not acceleration. We are not doing physics. All right. What is this going to give us? 3, good, equals. Now, here's a common mistake I do get. These are two separate terms because people will go, oh, this is 4 minus 1 is 3, and they'll put 3a. That's not right. They're two separate terms. -2 squared would be 4. So it's 4a and like then the -1. Just sort of tacked on at the end. Weirdly, I think you'd get the same answer anyway, but mathematically it's not correct. So you would add over the 1, divide by 4, a equals 1. So set them equal and then plug in whatever the value is. All right, how about the rest of this page? Oh, and you know what? I'm really sorry, and I need to go back and fight with this graph on the computer, try and fix this. Let me zoom way in. This is an issue, and I need you to just like scribble it out or fix it for me. Do you see how both of those circles are filled in? So it would fail the vertical line test. Are you following me there? One of them needs to be open, and I don't really care which one, but like one of those needs to be an open circle. Do you see what I'm saying? Let's see. I don't know. If you just write yourself a note, one of them needs to be an open circle. Do we want to do question 8? Maybe let's do question 8. State the values where this graph is discontinuous, and we'll state if they're removable or non-removable. All right, so where do you see a discontinuity? I'll go ahead and tell you there's 3 of them. X equals what? Where do we have one? -5. Are you going to do them left to right? Because if so, I absolutely love you. I need to do them left to right as well. So x equals -5. Is that removable or non-removable? Good, because you could fix it if you could just put the point back. Oh yeah, like plugging up a wall. Like, yeah, I know what you're talking about. All right, where is there another one? 0, good. Removable or non-removable? It is non-removable. Why? You can't fix it. You can't reconnect that. It's actually broken. Yep. All right, and then where's the last one? X equals 4. It's invisible, but what have we got going on at 4? Asymptotes. So that is also non-removable. You can't reconnect that. And then we're just going to state the domain and range. Yeah, there's going to be a lot of unions in this. All right, reading left to right. And in my brain, it's like scanning, 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 you know, like a radar thing. All right, so scanning left to right. Do we lose out a point at -5? No, we still got it. All right, so we got all of that. Do we lose out a point at 0? No, we actually get that one too. Actually, there won't be a lot of unions. We have all those points. What's the only value we're actually losing? 4 is the only one that we have to actually skip over. Now, if this point was not here, floating out in space, like if that wasn't there, then we would also have lost -5. That would also have to be like kicked out of the domain. All right, so range, let's see. Now we're gonna go downwards to upwards. So downwards to upwards, now we do actually lose a y value here. What y value are we missing? We're missing -2. So as we scan downwards to upwards, we miss -2. Let's see, I think we're pretty good everywhere else though, aren't we? As I scanned through, I feel like the pencil goes through all the other points. We missed -2, but we pick up everything else, so that's it. It looks very disjointed, but you actually still, as you scan left to right and downwards to upwards, you still get a lot of the points. Let me see if we have time for number 9. Do you guys want to do number 9? I feel like 10 went well on the quiz. I want to do the last 2. Oh, my numbering got off of there on the back. You know what? I think we'll do 9 and then we'll do the last 2 because I think you'll be fine on 10. Yeah, I numbered it poorly. I need to go back and fix that. I go back and tweak things each year and then I just don't renumber it and I apologize. You'll be okay. Let's do 9 though, because I feel like this was one where we struggled on the quiz, so I want to fix it. Where's the cut point on number 9? Don't fade out. You can do it. 2. Is 0 smaller or bigger than 2? Good. So we want to use the first piece. If you plug 0 into the first piece of the function, what do you get? 3. We're plugging 0 in right here. So 2 times 0 would be 0, and then plus 3 would be 3. All right, is 1 bigger or smaller than 2? Smaller, so we're still using the first piece. If you plug 1 in there, that will be 5. And then 2 is the tricky number. Which piece does 2 actually belong in? Good, because that's where the equal to is. All right, this one's a little tougher. I'll talk you through it. 2 minus 3. -1, but squared is 1 minus 1 is 0. All right, now let's graph this. This part's going to be linear. This part's going to be linear, and we're only going to graph it up to 2. What kind of circle? Open. Good. So I would go up 3, and your slope is 2. So it's going to be up 2 over 1, up 2 over 1. It's just when you get to 2, that's where the break is going to happen. So it's going to look kind of like a clock hand pointing sort of at like 7 o'clock. Again, if you want to graph the whole thing and then just sort of erase the part you don't want, you can do that too. Yes, ma'am. That counts, yes. Yes, and you have to put that one there, like, because. All right, now this one, you would want to start at 2. Oh my gosh, we already plugged in 2. Eyes open. You're gonna make it. When we plugged in 2, what did we get? 0. All right, so 2, 0, you can put a filled in circle because that's the equal to. And then you want to plug in a few more numbers bigger than 2. It should look like a parabola. So let's try like 3, 4, 5. Let's, you need to be able to figure out that it's a U shape. 3 minus 3 is 0, squared is 0, minus 1 is -1. So we get 3, -1. And then if we do 4, 4 minus 3 is 1, squared is 1, minus 1, 0. Do you see where we found the turnaround? As long as you get it to turn around, because it should look like a parabola. Well, it should look like a piece of a parabola. I have to tell you guys though, like, and I know you only saw your quiz, I graded like over 50 of them, but like on average overall, the one on the quiz where you guys had to draw a graph was very good, better than last year. It was very good. You guys graphed well. That is non-removable because you can't reconnect it just by putting a point back there. All right, and hey guys, we're gonna do these last two. Hey guys, I have over 10 minutes. These are your intermediate, well, do you want me to skip them and then you're just on your own? Okay, these are your intermediate value theorem. The function has to be what? Good. And then intermediate means in between. So you're trying to prove that something is in between two other values. So here's our function. Is there a value on this interval that will give you -2? Here's what you have to check. You have to check these two outputs and see if -2 is in between them. So let's plug in -2 and let's plug in 3 and see what we get. Okay, we need to see what those outputs are and see if -2 is in between them. So here we go. If we plug in -2, -2 squared, 4, and then negatives would cancel, so that would be +10. 4 plus 10 is 14. -2 squared would be 4. -2 times -5 would be 10. So 4 plus, yeah, like all the negatives kind of canceled out. And then if we plug in 3 squared, 9 minus 15, 9 minus 15, -6. So here's the question. Is -2, which is the value we're trying to prove, in between those? Yes. Is this function continuous? Well, it's a parabola, so yes. Here's how you write it. Since f of x is continuous, and you can abbreviate, and I don't care about your spelling, but you have to mention continuity. You do that, you get a point. So if you lose your mind, say the function's continuous. You know what I mean? I'll give you something. Since f of x is continuous, and here's where you mention in between. You can write it in words. -2 is in between f of -2 and f of 3, but here's the shorter way to put it. F of 3 is smaller than -2, which is smaller than f of -2. This one's -6 and this one's +14. So -2 is in between them. But if you want to write it out in words, that's fine. Like you do you, whatever. But you have to mention continuity. You have to mention in between. So since all that is true, there is a value f of c equals -2. Like that's the whole conclusion to the whole thing, is that that value exists. It's there. We proved it. We're amazing. And then the last one is the same thing, but on a table. Consider the values given for the continuous function f of x. On what intervals do we have to have a 0? The tricky thing is this. Is 0 positive or negative? It's neither. That doesn't count and you can't use it. Okay? I need to find a place here where we actually have a change from positive to negative or vice versa. So do you see a place where that happens? Good, from 4 to 5. Do you guys see that? Positive to negative. 0 doesn't count. You can't use that. Do you see anywhere else? Because sometimes there's more than one. No, that's it. Okay. On what intervals must there be a 0? I know that justify word is scary. Okay. There is a 0 on 4 to 5 because the function is what? What do you have to mention? Continuous, because the function is continuous. And I know justify is a scary word, but why'd you pick 4 to 5? Because you're right. Why'd you pick it? Like 0 is in between those. You can say 0 is in between those, and I'll even accept that it changes sign there, because that's a shorter way to put it, so I'll accept that as well. There's a 0 on 4 to 5 because the function is continuous and changes sign. Or you could say 0 is in between f of 4 and f of 5. That's a little lengthy. I'll take this because I feel like that still gets the point across. I'm not actually 100% sure they'll take that on the AP exam, but I will.